Hi students, welcome to another classes. In this video, we will discuss some important oxides in D block elements in 3D series. So first element is scandium. Scandium can form only one oxide. That oxide is Se2O3. Se2O3. Titanium can form some more oxides. So TiO, Ti2O3, and TiO2. Next, vanadium. Vanadium can form some more oxides, extra oxides. VO, V2O3, VO2, V2O5. Next, chromium can form oxides. Cr2O, CrO2, Cr2O3, CrO2, CrO3. Next, manganese. Manganese can form more oxides, MnO, Mn2O3, Next, MnO, MnO2, Mn2, Mn3O4, MnO3, Mn2O7. Stable oxides, MnO, MnO2 are stable oxides in manganese oxides. So next, iron. So iron can form FeO, Fe2O3, Fe3O4. Next, cobalt. Cobalt oxide is the most stable oxide. Form cobalt trioxide and COO2. And nickel, NiO and Ni2O3, NiO2. Copper can form Cu2O and CuO, and zinc form only one oxide, that is the ZnO. So this is the stable oxide for zinc. +2 is most stable. Copper, these two oxides are most stable oxides. When compared to CuO, Cu2 is a more stable. Scandium, the only one and only one oxide, that is the most stable oxide, that is the basic oxide. Here titanium, this oxide is a basic oxide. This oxide also basic oxide. These two oxides are basic oxides. This is also basic oxide. This is the amphoteric oxide. In titanium, this is the amphoteric oxide. In titanium form three oxides. TiO is the most stable oxide. Ti2O3 is trioxide. TiO2, when compared to all oxides, TiO2 is a most stable oxide. That is the amphoteric nature. TiO2 is a amphoteric oxide. So vanadium can form some oxides. So this is the basic oxide. This is also basic oxide. These two are basic oxides. So this is a amphoteric oxide. This is the acidic oxide. But as per NCERT syllabus, this is a amphoteric oxide, but more acidic properties are there when compared to basic properties. More acidic properties. More acidic properties when compared to basic nature. Acidic nature is more, but as per NCERT syllabus or NCERT textbook, that is the amphoteric nature. So which of the following is more acidic? This is the more acidic when compared to this. Which is the acidic oxide? V2O5 is acidic oxide. Which are amphoteric oxide? VO2 and V2O5 are amphoteric oxides. In chromium form, more oxides, Cr2O and CrO, Cr2O3, CrO2, CrO3. CrO3 is acidic oxide, and these two are amphoteric oxides. These two are amphoteric oxide. These two are amphoteric oxide. These oxides are basic oxides. These oxides are basic oxides. These are amphoteric oxides. These are acidic oxide. So number of oxidation number increases. Oxidation number of central atom increases. Acidic nature increases. Oxidation number increases. Acidic nature increases. Oxidation number increases. Acidic nature increases. CrO is a basic nature. These oxides are amphoteric oxide. These oxides are acidic oxide. Here most stable oxides CrO3, Cr2O3 is a most stable oxide. Most stable oxide. So next, manganese oxides are very important oxides. Manganese oxides are very important oxides. Monoxide, Mn2O3, MnO, MnO2, Mn3O4, MnO3, Mn2O7, Mn2O7 and MnO3 are acidic oxides. These two are acidic oxides. So these two are amphoteric oxides. MnO2, Mn3O4 are amphoteric oxides. These two are amphoteric oxide. These oxides are basic oxides. These oxides are basic oxides. Here most stable oxides. Here most stable oxides, MnO. Here also MnO. These are most stable oxides. MnO is a most stable oxide, and MnO2 also most stable oxide. MnO2 also most stable oxide. In oxidizing agent, in presence of oxidizing agent, MnO convert to MnO2. MnO convert to MnO2. That is a very important, very unstable explosive oxide. Very unstable explosive oxide is Mn2O7. Mn2O7 is a very explosive oxide. Very explosive oxide. Mn2O7 is a highly explosive oxide. That is a very important oxides. So these are oxides of manganese. These are oxides of manganese. MnO, Mn2O3, MnO2, Mn3O4. Here Mn3O4 is a mixed oxide. Mixed oxide, that is contain MnO and MnO2. MnO and MnO2. That is a mixed oxide that is easily decomposes to give oxygen. That is easily decomposes to give oxygen. So iron oxides, iron oxide Fe2O3 and Fe3O4 are most stable oxides. So this is the mixed oxide. This is also mixed oxide. FeO and Fe2O3 is there. Fe2O3. So this is the mixed oxide. It is a mixed oxide. It is a mixed oxide. So Fe3O4 is a mixed oxide. It contains FeO and Fe3O4. These all are basic oxides. So most stable oxides Fe2O3 and Fe3O4. These are most stable oxides. These are most stable oxides. So cobalt and nickel heavier elements, that is the cobalt, more atomic number elements, cobalt, nickel and zinc, copper. These elements form oxides, simple oxides, NiO, CuO, ZnO. These are most stable oxides. These are most stable oxides. Cobalt, CuO is a most stable oxide. Here most stable oxides. These oxides are hydrated oxides. hydrated oxides. Which of the following oxides are hydrated oxides? These are hydrated oxides. It's not a very less stable oxides. In cobalt and nickel, +3 and +4 states are very unstable. +2 state is very more stable. Common oxidation number, all d block elements are +2, but scandium mostly form +3. Why? Because so after losing of 3 electrons, that element get inert gas configuration. In titanium, TiO2 is a more stable. TiO2 is a more stable. Why? Because titanium lose 4 electrons, get inert gas configuration. Inert gas configuration. That is a very important, students. So these are hydrated salts. These are not hydrated oxide, not in neutral oxide base like neutral oxide, but that are unstable, very unstable compounds. That are very unstable compounds. And copper oxides, both are basic oxides. Both are basic oxide. Sometimes CuO considered as amphoteric nature. CuO considered as amphoteric oxide. And ZnO is a pure amphoteric oxide. ZnO is a pure amphoteric acid. But here more basic nature is there. CuO have more basic nature. So we have like V2O5. V2O5 is a more acidic nature, but this is the amphoteric compound according to NCERT. So these are basic oxides. This is the amphoteric oxide. Zinc oxide is a amphoteric oxide. Zinc oxide is a amphoteric oxide. That are very important. How to identify these are amphoteric acid? That amphoteric acid react with both acids and both bases. Both acid and bases. Amphoteric oxides are react with both acids and bases that are called as amphoteric oxides. What are amphoteric oxides, students? So ZnO is amphoteric oxide. Already know that BeO in before video. Al2O3 and Ga2O3 and arsenic, and fourth group SnO, SnO2, PbO, PbO2, PbO2, and next arsenic, As2O3, As2O3 and Sb2O3 and TeO2, PoO2. So next in D block, some are amphoteric oxides are there. This is the basic oxide in this titanium oxide. Next here VO2, V2O5. So next here Cr2O3 and CrO2. In this manganese MnO2, Mn2O4. So next iron, there is no amphoteric oxides, and ZnO is a amphoteric oxide. Here ZnO is a amphoteric oxide. These are amphoteric oxides. So which of the following are amphoteric oxides? Which of the following is basic oxides? Which of the following are acidic oxides? That is the very important, students. This is the information about oxides. This video is very useful for you in based on these 3 videos about oxygen, oxides of P block, oxides of D block. Will be more bits will become in competitive exams. Okay, students. Thank you very much, students.